applied when we measure the atomic mass. Since that we know that the atom is very small, okay, to measure the mass of that atom is really difficult. So what has been done is that, let's suppose we take this atom. As of now, there was no unit. There's no unit as such for the atom's mass. Okay, so first of all, we needed to establish the unit, because we have understood the importance and the need of the unit just now by looking at the kg example. Okay, so what we did was, we had this carbon 12 atom. Okay, and let's suppose the same concept here. The mass of this carbon 12 atom comes out to be x. Whatever mass we have, still no unit, comes out to be x. Okay, now we divide this carbon 12 atom into 12 equal pieces, right? Into 12 equal pieces. Now, I think this is simple mathematics, that if I ask you, this is one out of the 12 equal pieces, okay? This is one out of the 12 equal pieces. What is the mass of this one out piece? Can I say it is x divided by 12? But yes,
Yes,
x divided by 12. And what is x? Can I write it like this? Mass of carbon 12 atom, the 1/12 the mass of carbon 12 atom. Yes, 1/12 the mass of carbon 12 atom, because I have divided the total mass of the carbon 12 atom into 12 pieces. Yes, and I have considered this as a unit for measuring the atomic mass. Yes, and I'm simply saying I have taken this as the reference point. I've taken this as the standard unit or the reference point against which I will be measuring all other masses of the atoms. Yes, in comparison to this mass, in comparison to this, the mass of this one piece out of the 12 equal pieces of the carbon 12 atom, I will be measuring all other masses of all other atoms. Yes. So example, when I measure the mass of the oxygen atom, okay, it came out to be 16 times this mass, the mass of this, right? It came out to be 16 times the mass of this. And what is this? This is 1/12 the mass of carbon 12 atom. And what is this? This is the unit. So can I say the mass of the oxygen atom is 16 units? Yes or no? Please say yes or no. Bethi
yes,
Lokya, clear? Yes or no?
yes, ma'am.
Lokya, is it clear now?
Yes, ma'am.
Should I explain again? And when we measure the mass of one hydrogen atom, okay, one hydrogen atom, it was exactly equal to the mass of this. It was exactly equal to the mass of this. So can I say the mass of the hydrogen atom is 1 U? That is 1 unit. Yes, clear. The mass of this thing, carbon, was 12 U. Why was it 12 U? Why was it 12 U? See, carbon 12 atom had 12 equal pieces, right? 12 equal pieces. Definitely the mass of the carbon 12 atom will be 12 times the mass of this, because you are repeating this small part 12 times, right? So what do we get as the mass of the carbon? We get 12 U. Is it clear? Should I start now? My next point. Amar has still not joined. Just a second. I'm starting now. Fine. So, yes, and Nikhil has also not joined. Mhm. Nikhil has joined.
Sorry, ma'am. I had a network issue. Sorry, ma'am.
Okay, no worries, no worries. Fine. I'm starting with that. So, see, now I will quickly go through. This is what we have now according to the IUPAC, and we have already discussed yesterday what is the IUPAC. It's the main body, okay, which actually regulates all the rules and the regulations regarding the chemical applications and the chemical discoveries. Fine, okay, that is the IUPAC. Now, according to the IUPAC, this is what we have as the standard unit. And what is the standard unit for the atomic mass unit? What is the atomic mass unit? That is 1/12 the mass of carbon 12 atom. Yes, that has been taken as the reference point, as the standard point, as the atomic mass unit, and it is in relation to this mass that we are measuring the mass of all other atoms. That should be clear. Fine. Now we have somewhat historical perspective here, some quick historical background. Okay, so the first reference point that was taken as the unit, that was just simple carbon 12 atom. Okay, whole carbon atom. carbon 12 atom as a whole.
Ma'am.
What are we using as of now? We are using just one part of out of the 12 equal pieces, okay, of this carbon atom. Earlier, what was the first thing that was done? This full atom was used. This full atom was used as a standard reference point. Example, let's say I have this unit, okay, and I've kept this in the measure in the weighing balance, okay. And if I measure the mass of all other atoms in relation to this carbon 12 atom, yes, I will get the mass of these atoms. Yes, I will get how many times are they more or how many times are they less or are they equal or whatever are they, we will get the mass of other atoms. Yes. And the problem with this was that we were not getting, we were getting the atomic mass in decimal form. We were getting the atomic mass in decimal form. And that was not very convenient. That was not very convenient for the usage. Therefore, something else has to be used, which can give us whole numbers. Yes, which can give us whole numbers at the values of the atomic mass. Yes, bacho. So therefore, the next standard unit that was taken was oxygen 16 atom. Was oxygen 16 atom. Was oxygen 16 atom. And we will quickly see why was oxygen 16 atom taken. Fine. So we will go through the reference historical perspective very quickly. Fine. See, bachcho, come here. Carbon, fine. We defined the atomic, please, this is important, please pay attention. We defined the atomic mass unit, earlier abbreviated as AMU. Now, what do we write the unit as? We simply write it as U. We simply write it as U, that is unified mass. Earlier, we were writing 16 AMU as the mass of oxygen atom. Now, we will just write 16 U. Is it clear? Is it clear? First point. Second point, as equal to the mass of one carbon atom. As equal to the mass of one carbon atom. The first point that I just now explained. Earlier, we were using the full carbon atom as the reference point. As the reference point. Clear? Now, if we are saying, see, but you see, please understand this thing. If we are using as the reference point, definitely we are using this as the unit. Now, the mass of this full carbon atom could be called as one unit. Yes, but could be called as one unit. Are you getting this? That is why it is said that as the equal to the mass of one carbon atom. As equal to the mass of one unit was equal to the mass of one carbon atom. I hope that is clear, right? Then we would
Ma'am,
assign
can you
carbon an
repeat it?
atomic mass of 1U. What point, bachche? The
Ma'am,
same point? Yes, yes,
can you
Yeah,
repeat it?
ma'am. Can you repeat
yes,
it?
yes, I can repeat. Fine, fine, fine. I can repeat. No hurry. The statement is saying that earlier we were having the unit as AMU, but later on we changed it to U. This is the first point set, okay? And what are they saying? That the one unit is equal to the mass of carbon 12 atom, whole carbon 12 atom. Why? Because see, if you are having this as the carbon 12 atom, okay, and whatever the mass comes in, let's suppose this comes out to be x, okay. I have considered this value of x as one unit, right? Now I will be measuring other masses in comparison to this. Therefore, it is called as the unit. Now, what is the value of my unit? The value of my unit is equal to the mass of carbon 12 atom. Yes, Bachu? What is the value of my unit? It is equal to the mass of carbon 12 atom, full carbon 12 atom. Please
Yes, ma'am.
recall that the value of 1 kg was equal to the mass of that box. The value of 1 kg was equal to the mass of that box. Yes, Nikhil? The value of 1 kg was equal to the mass of that box in the first example that we tried to understand. Yes, it is the same point here. If we have taken the mass of this full carbon atom as the unit, then what is the value of my unit? It is this, the mass of carbon 12 atom, right? It is this, the mass of carbon 12 atom. Now, if I have this as the unit, what will be the mass of carbon 12 atom? According to this reference point, it will definitely be one unit. It will
X.
definitely be one unit. Yes or no? Are
Yes,
you
ma'am.
getting this? All four of you are clear with this idea?
Yes, ma'am.
Yes, ma'am.
Any problem, any confusion? With the
Ma'am.
Faraz, बच्चे clear?
Yes, ma'am.
Yeah, ma'am.
Fine. Correct. Now, so the same thing, I will repeat it here again. We defined the atomic mass unit. We defined the atomic mass unit as equal to one carbon atom mass, right? Clear? Fine. Then on this basis, we will assign carbon an atomic mass of 1U because it is equal to that. We are really taking that as the unit. Clear? Clear? Please respond, Bacho. I need the response. Then
Yes,
only
ma'am.
I
Yes,
can
ma'am.
decide.
Yes, ma'am.
Yes,
Yes, ma'am.
fine.
Yes,
Okay.
ma'am.
And then let's suppose we have this as the carbon 12 atom and I have taken this as the unit And when I try to measure the mass of the oxygen atom in relation to this, it was coming out to be 1.33 times the mass of this unit, that is mass of carbon-12 atom. The mass of the oxygen atom was coming out to be 1.33 times the mass of the carbon-12 atom. Therefore, 1.33 U. Therefore, 1.33 U. Yes, now go ahead.
Uh, Ma'am, I did not understand the point. Your voice was breaking in between. Can you repeat it?
Okay, okay. What did you not understand, Machi? Can you tell me that? Till where were you able to listen?
Ma'am, like when you drew the atom diagram, it suddenly started to break, and then the
Okay,
drawing
okay. Just
like
this point, right? The slide where whatever I was explaining on the slide, that is clear.
yes, ma'am.
Fine. I will explain this again.
Ma'am, that means it's like 3 by 4, right? I mean 4 by 3. 4
4
is
by
to
yes.
3.
Yeah, the same concept that we were getting here. Yes. See, Nikhil, I was repeating this point. We define the atomic mass unit as the mass of one carbon atom. That is what we are saying. We have taken that as one unit. Therefore, what is the value of one unit? The mass of one carbon atom. Clear? And if we have taken that as the unit, if I have taken the mass of carbon atom as the unit, clear, as the unit, if I compare the mass of oxygen atom, if I compare the mass of oxygen atom with this, it comes out to be 1.33 times. Therefore, can I say the mass of the oxygen atom is 1.33 U? Because I've taken
Yes,
this mass
ma'am.
as a
Yeah,
unit.
ma'am.
Yes,
Yeah,
that is
ma'am.
the whole point here. That is the whole point here, right? We get the mass of the oxygen as 1.33 U. However, it is more
Uh,
convenient to have these numbers, just a second, have these numbers as whole numbers or near to a whole number. The same point that I explained you, we were getting the values in decimals, and that was not very convenient. We wanted to have the values of atomic masses as whole numbers. Yes, Mithun, go ahead.
why did they take
You were saying something.
particularly carbon 12 for
Why
measuring
did they
the
particularly take?
carbon 12 for
See, there are
measuring
many
the
reasons. See, first of all, we need to have the stability of that, and we will see why oxygen was discontinued. There were many isotopes, okay? So there were inconsistencies. Therefore, the best part, the stable and the most consistent, we were getting as carbon-12 atom, okay? So we have to see many factors that would really account for that. I hope that answers
Yes,
your
ma'am.
question.
Yes,
Yeah,
ma'am. Yes, ma'am.
fine. Now, see, while searching for various, now what is the problem? So, the mass of the carbon atom, as full carbon atom as the unit, that has to be discontinued. Why? Because when we are using that as the unit, we are getting the values of other atomic masses in decimal form, right? So that has to be discontinued, right? That has to be discontinued. Now, what's the second option that has been chosen? While searching for various atomic mass units, again, focus on this units because we are trying to search for a unit. Scientists initially took 1/16 the mass of an atom of naturally occurring oxygen as the unit. Now, this is the second unit that we are getting. Let's say this is the naturally occurring oxygen. This is the naturally occurring oxygen, okay? The mass of this comes out to be Y. The mass of this comes out to be Y, okay? What we say, I divide this mass into, I divide this atom into 16 parts. So definitely I will get 1/16 the mass of the naturally occurring oxygen, that is 1/16 of Y, right? And I have taken this as the unit now. I've taken this as the unit now. Is it clear? I've taken this as the unit now. Now I'll be measuring the mass of other atoms by comparing the masses to this mass, by comparing those masses to this mass. Please say yes or no.
Yes, ma'am.
Yeah, ma'am.
Yes, but it was discontinued. We will see why. And why was oxygen taken? Let's first see that. This was considered relevant due to two reasons. First, oxygen reacted with a large number of elements and formed compounds. This we are very well aware of. Oxygen is a very, commonly found element. So it is almost present in almost every compound. It reacts with almost every element to form the compound. Therefore, this was the first reason. Second, this atomic mass unit gave masses of most of the elements as whole numbers. That was what was our need, right? This is what was our need. We wanted the atomic masses in whole numbers. So oxygen 16, 1/16 of the mass of the oxygen, naturally occurring oxygen, was giving us the mass of all other atoms in the whole numbers. But this was also discontinued. This was also discontinued, and the reason is not mentioned in the NCRT, but the reason is that oxygen's isotopes were not very consistent. They were not very consistent. Therefore, while measuring the masses, okay, there were many inaccuracies. Therefore, it was discontinued. Now, in 1961, for a universally accepted atomic mass unit, again, unit, we are just searching for the right unit, okay? Carbon-12 isotope was chosen as a standard reference for measuring the atomic masses. This has already been explained. Please tell me, is there any confusion in this?
No, ma'am.
No, ma'am.
Fine. One atomic mass unit. Now see, this is very important. One atomic mass unit. Unit is a mass unit equal to exactly 1/12 the mass of the one atom of carbon-12. What we were writing? 1/12 the mass of carbon-12 atom, right? X divided by 12 simply. That one piece, okay? This is the atomic mass unit. Clear? This is the atomic mass unit. The mass of this is equal to the atomic mass unit. Clear? Clear? Fine. The relative atomic mass of all elements have been found with respect in relation to an atom of carbon-12. I hope that is clear. Please
Yes, ma'am.
respond, bachcho.
No, ma'am.
Fine. Fine. Imagine, so go through this. If you are having any problem, this is just a simple example to explain you the atomic mass. Please go
And
through
will
this.
it come in exam?
What? This?
Yes, ma'am.
This is just an analogy to explain you the atomic mass concept. I've used the concept of the box. Okay, they have used some other concept. Please go through this. I'm waiting. Please go through.
Yes, ma'am.
Yes. So what they are trying to say here, that they took this one piece of the watermelon, and whatever the mass of this one piece was, they took it for the unit, right? Now we are measuring all of the masses in respect to this mass. Okay. Let's
Yes,
suppose
ma'am.
the mass of our cherries come out to be 2 times equal to the mass of this piece, right? The mass of this piece. So I will say 2 units, right? 2 units simply. I hope that is
Yes,
clear.
ma'am.
The same example, the same concept. Nikhil, is it
Yes,
clear?
ma'am.
Fine. Lokya, Bethel, Faraz, Bache.
Yes, ma'am. Yes.
Fine. So see,
Yes,
similarly,
ma'am.
the relative atomic mass of the atom. Yes, thank you. The atom of an element is defined. This is important. Is defined as the mass of the atom as compared to 1/12 the mass of one carbon 12 atom. Right? Comparison same. I've already explained it. I hope that is clear. Moving on to the next.
Yes,
But you see, we have also discussed the common atomic masses for all other common elements. See, hydrogen we have discussed. Hydrogen we have discussed, that comes out to be 1U. Carbon comes out to be 12U, and I explained you why it comes out to be 12U. Yeah, yes, because 12 times equal pieces were being repeated. Definitely it is 12 times the mass of that one piece. Okay. Nitrogen comes out to be 14U. Very important. Hydrogen, carbon, nitrogen, oxygen. Very, 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 very important.
ma'am,
Okay.
you said some element which will be equal to carbon, right? I forgot that.
Huh?
Same 12 week.
Sorry? What? I'm not able to understand your question.
You said another element which is also 12U.
Which is also 12U. No, I did not say that.
Ma'am, he's asking whether there are any atoms that is isobars, like is carbon isobar?
Okay. Carbon 13 and nitrogen 13, they are isobars to each other. Some isotopes of carbon and some isotopes of nitrogen
Ah,
are isobars to each other.
yes, ma'am.
They are. But those are other isotopes, not the carbon 12 isotope. Okay. Fine. So these four are very important. At least you should have these on your tips. Okay. All these are also important, but at least these four are very, very, very important. Fine. Now moving on to the next. Should we move on to the next topic, Bacho?
Yeah,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Now, one point that I quick thank you for reminding this, hopefully. This is who basically gave the concept of atomic mass. It was John Dalton through his theory, okay, through the third postulate and the fourth postulate of his theory, because in the third and the fourth postulate of his theory, he was talking about the atomic masses. Yes. What was he saying? He was saying that the atoms of the same element will have identical atomic mass and the atoms of different elements will have different atomic mass, right? So who was the one who first, gave this idea of atomic mass? It was Dalton through his theory, okay? Remarkable concept that Dalton's atomic theory proposed was that of the atomic mass. Okay, each element had a characteristic atomic mass. Fine. Is it clear? Fine.
Yes.
Moving on to the next part. That is, how do atoms exist? Yes. This has been discussed in detail in the second chapter. I will be rushing this topic up, and I expect all of you to recall the concepts discussed in the second chapter. I've discussed that. Let's suppose we have one atom. This is from the second chapter. Please pay attention. Let's suppose we have one atom. Okay. Now we know that one atom will not exist as one atom because first of all, what we see around ourselves is microscopic matter, right? And we know that many atoms would have combined together to form the matter that we see around ourselves. Because one atom is very small, not really even not really able to exist on its own, not even visible. Fine. So therefore, how do atoms exist? Definitely not as individual atoms. Definitely not as individual atoms. So how are they existing? Definitely in some combination. Definitely in some combination. Fine. See, atoms form molecules and ions. Atoms forms molecules and ions. See, they are not able to exist independently and they form molecules and ions. These molecules or ions aggregate, that is, they form a cluster in large numbers to form the matter that we see, feel, or touch. The same concept here. The matter that we are able to see around ourselves definitely will have many atoms, right? They will have many atoms. So even if atoms are forming this molecule, okay, many molecules of these two atoms will be present in the matter that we are able to see around ourselves. I hope the concept would be clear. Fine. So
Ma'am,
what we need to learn? What is yes?
ma'am, so ions are like generally like molecules.
No, ions are not generally like molecules. Ions are the charged species. Okay, ions are the
Oh,
charged species. I'm coming to that in a minute. Now, what is a molecule? As discussed in the second unit, molecule is nothing but a group of two or more than two
Group of
atoms that are
atoms.
chemically bonded. Yes. And I hope you will be able to recall that I emphasized on this part too much that they're chemically bonded. Chemically bonded. Yes. What kind of bonding is present in the molecules? They're chemically bonded. Clear?
Ma'am,
Tightly held together by attractive forces. Yes.
two atoms are enough for making a molecule?
No. Yes. See, yeah, basic number has to be two. We can have more than two, that's fine. But at least there should be two atoms, right? For it to be called as a molecule. Because what is molecule? A group of atoms. How can I have a group when I just have one atom or one person, right? So basic, minimum two. I hope that
Yeah.
was your question. A
Yes, ma'am.
molecule can be defined as the smallest particle of an element or a compound that is capable of an independent existence and shows all the properties of that substances. Why? All of you think over this and explain me. Basically, they are saying that molecule is the smallest, independent species that could be that can exist. Why? Are you able to recall that we discussed something in the second chapter that was the I'll open it here. Elements are the basic form of matter, the basic form of matter that exists. Yes. Are you able to recall that? I'll write it. An element is a basic form of matter that cannot be broken down into simpler forms by chemical reactions. Are elements molecules? Say yes or no. Are elements molecules?
Yes, ma'am.
Yes. Elements are also molecules. Yeah. So basically, what we are trying to understand here is that one atom. Let's say I have one atom. Okay. Now this one atom is definitely not existing as one atom. Okay. So either it is bonding with the same type of atoms. Let's say this is one molecule. Yes. Or is it bonding with different types of atoms? But then also this is a molecule. So basic, like the basic species which is existing independently is what? A molecule. Okay. Whether it's an element or whether it's a compound, whether it's a molecule of an element or whether it's a molecule of the compound, it is the molecule which is existing independently. I hope that is
Ma'am,
clear.
what about atom?
Atom, but we just now said that it is not able to exist independently. It is in bonding with something else, with some other atoms. And when it is in bonding with some other atoms, it is forming the molecules. It is forming the molecules. Just a second. Yes, it is forming the molecule. Yes, is it clear, Method? Uh, all of you need to respond. All of you need to have the cameras on.
Ma'am,
Yes.
can you just give me 50 seconds? I'll just come again.
Okay. Bethel, bacha, you understanding some of it? Because you missed the classes, I think last 2 classes, but I hope you will be able to understand this.
Yes, ma'am.
Faraz,
Yes, ma'am. Understood.
Nikhil. Nikhil is not present. No, Nikhil is present, I think. No, Nikhil is not present. Fine. All of you are having your exams going on currently?
Yes, ma'am. Yes, ma'am.
What's the next exam that you have, Lokya?
Ma'am, I have social.
Social sciences. When is it?
Day after tomorrow.
Day after tomorrow. Okay, so you have basically 1 day gap in almost each of the exam, right?
Yes, ma'am. Alternate
And
days.
okay. And how did the maths exam go today?
It was easy.
Ma'am,
Uh-huh.
sorry, ma'am. Again, I got disconnected.
No worries, that's fine. You have yet not done anything. Fine. Should I start now?
Ma'am,
Yes, ma'am.
where did you leave? You just started molecules.
No, I discussed why is molecule the smallest particle of an element that is capable of independent existence. Nikhil, you wait for this in the last after the class. Okay, I'll explain this to you again. Okay,
Okay, ma'am.
fine. So atoms of the same element or of different elements can join together to form the molecules already discussed. I hope no problem till here. Okay. Now, molecules of elements means what? When same atoms are combining together to form the group. This group is what? The molecule. This group is what? The molecule. Either one atom can be like this, or two atoms can be combining together to form the molecule. Example, oxygen. That is O2. That is also an element. That is also a molecule. But two atoms of the two atoms are combining together to form the molecule. Yes. Therefore, it is also an element, a molecule of an element. Clear? Fine.
Yes.
See, the molecules of an element are constituted by the same type of atoms. Molecules of many elements, such as argon, helium, are made up of only one atom of that element. These are inert gases. These are what? Inert gases. Okay. Now, when these are inert gases, they basically do not react much. When they do not react much, they will obviously not be bonding to other atoms as such, because they do not need other atoms to have to be present in combination with them. Therefore, they are able to exist as single atoms, not as independently, but rather in the elemental form. But are you saying that is there any specific combination? Like let's say for oxygen, these two atoms are there. Okay. Now this is O2, 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 O2. Now this is the molecule of element for oxygen. But for argon, argon. Like this is the element of argon. Are you getting the difference? What is the basic unit of the
Yes,
oxygen
ma'am.
Yeah,
element?
ma'am.
That is O2. That is O2. What is the basic unit of the argon element? That is just the argon atom. Okay, clear? And these
Yes.
are all inert gases. If you
Yeah,
want to
ma'am.
write it, please write it down. Okay. See, but this is not the case with most of the non-metals. A molecule of oxygen consists of two atoms of oxygen. Hence, it is known as a diatomic molecule. Atomicity simply refers to how many atoms are combining together to form the one molecule of that element. Atomicity refers to how many atoms are combining together to form one molecule of that element. Is it clear? For example, for the monatomic gases, that is helium, argon, neon, we need just one atom. Right? So what are they? They are monoatomic elements. What are they? They are monoatomic. Mono means one. So therefore monoatomic molecules. Now in oxygen, what are we seeing? We need two atoms of oxygen to form one molecule of this element, right? To form one molecule of this element. Therefore, two atoms. Therefore, diatomic. Di means two. Okay. So diatomic molecules. If we have ozone, but so if we have ozone, that is O3. So three oxygen atoms are combining together to form one molecule of this element. Can I say it is triatomic? Tri means three. Can I
Yeah,
say it is
Yes.
triatomic? Yes. So what is the atomicity of ozone? 3. What is the atomicity of oxygen? 2. What is the atomicity
Two.
of helium? 1.
One.
Clear?
Ma'am, but
Yes, Sachin.
yeah, ma'am.
you said that like atoms cannot be independent.
That is what I was explaining to you here. It's not that just one atom is existing. It is in combination with all other atoms like this. Okay, but what is the basic unit here? That is just one atom. See, In case of oxygen, it is O2, O2, O2 being repeated. In case of argon, it is just argon atom, argon atom, argon atom, argon atom like this. Clear? I hope that makes sense to you. So that is why it's not existing as one. It is existing in combination as an element, okay? But is there any specific molecule present in that element? Like we have in the oxygen? No. Is that
No.
clear?
No. Yes, ma'am.
Therefore, it is
Yeah, ma'am.
monatomic molecule. Therefore, it is monoatomic molecule. Yeah. What's the atomicity for ozone? 3. What's the atomicity for ozone? 3. Yeah.
3.
See, if the atoms of oxygen unite into a molecule instead of the usual 2, we get ozone, that is O3. The number of the atoms constituting a molecule is known as its atomicity importance. Yeah. Now, metals and other elements such as carbon do not have a very simple structure but consist of a very large and indefinite number of the atoms bonded together. So basically, we can have very complex numbers for the atomicity also. Some common elements: argon, monatomic; helium, monatomic; oxygen, diatomic. Okay. If you want to write it, you can write mono means 1, therefore it is monatomic, di means 2, tri means 3, tetra means 4, penta means 5. Clear? So if you are able to understand the meaning, you will be able to memorize it easily. Mono means 1, di means 2, tri means 3, tetra means 4. Clear? See, hydrogen is diatomic. How do we write hydrogen? H2 is diatomic. How do we write chlorine? Cl2, right? What is it? Diatomic. Clear? I think that is clear. Sulfur battery is S8. Okay, so we basically do not have any specific number for that. We just simply say it is polyatomic. Okay, sulfur is S. How will I write P phosphorus? Can I write P4? This is one molecule of phosphorus. Yes, bache, because it is tetraatomic.
Yeah.
Method, is it clear?
Yes, ma'am.
Yes, ma'am.
Now the molecules of compounds. Simple. When two different atoms are combining together to form the molecule, it's the molecules of compound. Example H2O. Yes. Atoms of different elements join together in definite proportions to form molecules of compounds. I hope no problem in this statement.
No, ma'am.
Yes, ma'am.
No, ma'am.
Examples are given here. We have already discussed these examples when we were discussing the law of constant proportion. Water, H2O, hydrogen and oxygen are the combining elements. Ammonia, NH3, nitrogen and hydrogen are the combining elements. Carbon dioxide, carbon and oxygen are the combining elements. This is the ratio by mass, and I think we have discussed this in detail. Does anyone have any problem in this?
No,
No,
ma'am.
No,
ma'am.
ma'am.
Prithil? Fine. Now see, we are coming to the ion. But you please understand this concept. This is important. This is one atom, okay? This is one atom. Simple atom. Now, we know that the atom is neutral. By default, it is neutral. What is the nature of the atom? It is neutral. It is neutral, right? Now, due to some, reactivity of the atom, or we will be discussing the reasons in the fourth chapter. But as of now, just know that atom gains charge. The atom gains some charge, and we will discuss why and how. But the atom gains some charge. Okay. Now this was a neutral.
Ma'am, I couldn't hear you.
Ma'am.
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 Ion. The charge especially is called as ion.
Ma'am,
Yeah.
I couldn't
I
hear
think
you.
yes, I think my network is fluctuating. Yes, I got it. Fine. What I'm saying is that let's suppose we have a neutral atom, okay, and let's suppose for some reason the atom gains some charge. Initially it was neutral. Now let's suppose for some reason, and the reasons we'll be discussing in the next chapter, the atom gains some charge. The atom gains some charge. Now, since the atom has just a second has gained the charge, okay. Any charge species is called as the ion. Yes. Yes, Nikhil, go ahead.
Ma'am, are they like atoms, subatomic particles are electron, proton, neutron, right? So is that a thing like the more number of subatomic particles, the charges depend on that? Like proton means positive and electron means
Actually, it is not the
negative.
protons, that is right, but the concept there is that protons do not show any movement. It is the electrons which are showing the movement. Either the electrons will be lost or the electrons will be gained. If the electrons are lost, the atom will develop a positive charge. If the electrons are gained, the atom will develop a negative charge. Okay, that is the basic theory, and we'll understand as to why does this happen in the next chapter. Fine. Fine. Basically,
Okay.
any charged species, in this case, charged atom will be called as the ion. Charged atom will be called as the ion. Now see, we know that the charges could be of two types. If the charge is positive, bache, okay, we will call that as cation. Cation. Okay. If the charge is negative, sorry, we'll call that as anion. Clear?
Anion.
See, come here. The charged species are called as ions. Ions may consist of a single charged atom or a group of atoms that have a net charge on them. See, I can just eat rice. Or I can eat rice, dal, and plus some salad. Now I'm eating this as the net food, right? Now this net food can have some charge. Either the rice can have some charge or this net food can have some charge, right? What is this? Group of foods that I'm eating. Therefore, the single atom can have some charge. That is also a charged species. Therefore, that is also an ion. Or group of atoms, that is a molecule, can also have a charge on it as a net. Okay, as a net charge on that. Clear? Clear, bachcho?
Yes, ma'am.
Fine. See, an ion can be negatively or positively charged. Negative is called the anion. Positive is called as the cation. Clear? And always remember the cation bonds to the anion. The cation bonds to the anion. The cation bonds to the anion. And NaCl is the best example for this. Na is a cation here. Chlorine, which is a anion here. Okay. Chlorine is then anion. And always remember one thing. The cations, okay, which are generally the metals, let us suppose this is in their initial atom form. Right? When they become the ion, that is positive ion, right? Because we are talking about the cation, their name will still be the same. Example, this was sodium atom. Okay. Now when it has become the sodium ion, it will still be called as a sodium ion. Here, it will still be called as the sodium ion. But when we talk about the anions, when we talk about the anions, okay, and it is generally the non-metals which behave as the anion. We'll discuss why, but it is generally the non-metals which behave as the anions, okay? And when ionize, let's suppose this was the initial atom, right? And when it has gained some charge, it has become the ion. And what kind of ion? Negative ion, right? What kind of ion? Negative ion. Its name will change. It's just a second. Yes, sorry for that. So its name will change. Example, it was the oxygen atom. Okay, it was the oxygen atom, initially neutral atom. Okay, but when the oxygen atom, I'm talking about the atom and not the element here. Please be mindful of that. When the oxygen atom gains a charge, okay, it will be called as the oxide ion. It will be called as the oxide ion. Clear? An example, we have chlorine. It is called as chlorine atom. And if it gains a charge, chloride ion. Clear? That is why we say sodium chloride. NaCl has sodium, that is the cation part. Na plus, since it's the positive ion, no name will be changed, right? And it is the chloride ion bonding with it. If you ever say it is sodium ion and chlorine ion bonding, it's wrong. It's always the sodium ion and the chloride ion bonding in the NaCl. I hope that is clear.
Ma'am, so like we call these things only the non-metals as the changing the names for ions.
Yes, generally. And or the second case is we have the group. Okay, sorry. We have the group of ions. I'll explain you here just a second. So we have the group of ions. See, we said that either the charge can be present on the single atom or it could be present on a group of atom as a net charge, right? And what is that? Basically a molecule. It's a molecule which is having a net charge, okay? And basically if it's a molecule, definitely the name will not be the same as that of the atom. If it's a molecule, definitely the name will not be same as that of atom. Example, this is the carbonate ion. This is a molecule, a group of atoms with a net charge of -2. The name of this ion is carbonate ion. Okay, this is carbonate ion. See this? This is the ammonium ion with a net charge of +1. What is this? Ammonium ion. ammonium ion. Clear? Next we have nitrate ion. NO3 with a net charge of -1. Nitrate ion. Okay. We have the sulfate ion. SO4 with a net charge of -2. Clear? So we have many of this thing polyatomic ion. These are referred to as what? Since there are many atoms, can I call them as polyatomic ion? Yes. Polyatomic ion. Simple.
Yes, ma'am.
Yeah,
So
ma'am.
these are examples of polyatomic ion. I hope the concept is clear. Is it?
Yeah, ma'am.
Yes.
Fine. Moving on to the next part. Fine. I've discussed till here, right? Yes. See? A group of atoms carrying a charge is known as a polyatomic ion. Simple, already discussed. Clear? Now see some ionic compounds. Some ionic compounds. What do we mean by compounds? Basically, compounds formed by the combination of ions. Positive ion bonded to a negative ion. Cation bonded to an anion will give you a ionic compound. Will give you an ionic compound. Example is NaCl. Example is NaCl. Okay. Let's quickly see some other examples. Calcium oxide. What are the ions present here? It is the calcium, and the other one is oxygen, which is present in the ionic form. Therefore, we call it as oxide. Is it clear? So, what are the elements? It is oxygen and calcium. Clear? Magnesium sulfide. So it will be the magnesium and it will be the sulfur. If you are talking about see, here we are referring to them in the elemental form. Had we been saying about the ionic form, I would have said magnesium and sulfide are the two ions here. Clear? Sodium chloride, sodium and chlorine. Clear? You know this, how to calculate the mass by ratio, right? I mean ratio by mass, right? Or if you can do this, try
Yes,
this.
ma'am.
Try solving the ratio by mass for calcium oxide quickly, very quickly. You have the table given, okay, in which you have the atomic masses of all the elements. Go through that very quickly.
You have to find the mass of each element.
Yes, just try to calculate the ratio here. That is calcium oxide. So you have calcium and you have oxygen. What's the mass of calcium? What's the atomic mass of the calcium element? 40, right? It is 40 U divided by 16 U. What do we get? 5 by 2.
2.5.
We can count. Yes, 5 by 2. So the common factor is 5, right?
Yes, ma'am.
0.75.
Huh?
Next is 0.75.
But what are you calculating?
Magnesium sulfate.
Huh? No. What are you calculating?
The mass.
Of?
First, I calculated calcium oxide. Now, I am calculating magnesium sulfate.
Okay. You are calculating the magnesium. But yeah, how are you calculating the mass? We'll just simply get the ratio. You have actually simplified that too much, right? 3 by 4. That is why you are getting some 0.75, right?
Yes, ma'am.
Fine. So just stop here when you get the ratio in the simplest form. Okay. Now see, the next topic is the writing of chemical formulas. I will discuss that in the next class. But before that, I want to discuss two topics here. I hope if I will take 10 minutes into this class, no one of you will mind it.
Yes,
Okay,
ma'am.
Better,
okay,
is it
ma'am.
okay with you?
Okay, ma'am.
Okay, I know it's a bit hard on you, but please try to manage it.
No
Next is
problem, ma'am.
social science. See, the next topic after the chemical formulas is the molecular mass and the formula unit mass. So I would quickly want to discuss that right now. Molecular
Ma'am,
mass. Yes, Bachchan.
if you don't mind, can I go after 10 minutes?
So I will stop this topic here. I'll discuss this in the next class. But before that, in the remaining 10 minutes, we'll discuss one thing. Okay. We have discussed about the elements. Okay. We have discussed about the molecules. We have discussed about the compound. Clear? Now, basically, if I tell you this is one hydrogen atom, I think you will say this is one hydrogen atom, right? This is one hydrogen atom.
Yes,
This
ma'am.
is one oxygen atom, right? This is one oxygen atom. What is this?
Yes, ma'am.
What is this?
Oxygen.
Oxygen.
Oxygen molecule.
Mm-hmm. So oxygen molecule is an element. Fine.
Yes,
If I
ma'am.
ask about if if I ask about the number of atoms in this oxygen molecule or element, what will be the answer?
2.
2. Because that's the atomicity. Because that's the atomicity. Fine. Excellent. If I ask you here, what is this?
Water.
H2O
What?
water.
That's molecule of a compound, right? That's molecule of a compound.
Yes, ma'am.
How
Yes,
many
ma'am.
atoms here?
3.
3.
Ma'am, 2 hydrogen and 1 oxygen.
2 of hydrogen, 1 of oxygen. 2 of hydrogen, 1 of oxygen, right? Now see, what we are going to learn in the next step is very important when you are going to measure, when you are trying to balance the chemical equations in the class 10. Okay. See, that is very important. We are going to learn how to know the number of molecules given in a particular information, how to know the number of elements involved in that, and how to know the number of atoms. Okay, the total number of atoms. Please pay attention. We'll just take 5 minutes. Let's say, bache, this is one molecule of water, right? This is one. I'll start with the basics here. Please understand. This is one molecule of water. In this one molecule of water, first I will write one molecule of water. Yes. And how do you know it is one molecule of water?
Because it's on. There
Ma'am,
are only.
atoms together combine one molecule.
Okay, but when we are talking about a molecule, okay, this becomes one entity here, right? This becomes one entity here. Clear? And the coefficient, whatever the coefficient is here, please understand this. Whatever the coefficient is
That will
here,
be
basically
2.
tells you the number of, just a second, bache, tells you the number of molecules. Clear? Now, if nothing is written, that means it's 1. So we are assuming here it is 1. The coefficient here is 1. Therefore, what is it indicating? The number of molecules. So can I say the number, it is 1 molecule here present? Yes, because the coefficient value is 1.
Yes,
Because the
ma'am.
coefficient value is 1. Clear? Now, in this one molecule of water, how many elements are involved? Elements.
2.
Ma'am, 2
2. That is hydrogen, namely,
and oxygen.
and oxygen. Yes. Now, in this one molecule of water, how many atoms of the hydrogen element are present?
1.
1.
Ah,
2.
2
Ma'am.
atoms. How many
Oh,
atoms of the
okay.
oxygen element are present?
1.
1 atom. Yeah?
1, ma'am. 1, ma'am.
Fine. So basically, what information, if I simply write H2O, I get 3 information from that just by writing H2O. It's one molecule. There are 2 elements present in this one molecule, and there are in total 3 atoms, 2 atoms of the hydrogen and 1 atom of the oxygen in this one molecule of water. Is that clear? Clear? Fine. Now I will write something else.
Yes, ma'am.
You will tell me now. Please pay attention. What information can you understand just by looking at this? What all information can you get
7
from this?
molecules of H2O.
7 molecules of water.
Ma'am,
Mhm.
2 elements.
2 elements. What are they, bache, for us?
Hydrogen and
Hydrogen
oxygen.
and oxygen.
Hydrogen and
Oxygen.
now tell me the number of atoms for oxygen and
3.
hydrogen respectively.
14 and
3
7.
atoms.
14 and
7.
14 for
ma'am,
oxygen and 7 for hydrogen, right?
Hydrogen. 14 for hydrogen.
ma'am,
Yes.
ma'am, I cannot hear you properly. There is some screeching background noise going on.
I know. Just a minute. Fine. Just a second. Yes. Now please all of you calm down and just listen. So we have 14 atoms of the hydrogen and we have 7 atoms of the oxygen, right? Now see, what do we get? First we have the basic unitary method. Yes, sorry for that. So basically, if we calculate it by the simple unitary method also, we say that in one molecule we have 2 atoms of hydrogen. Therefore, in 7 molecules, we'll have 7 into 2. Therefore, we'll have 14 atoms, right? In one
Yes.
molecule of water, we have 1 atom of oxygen. Therefore, in 7 molecules of water, we will have 7 into 1, that is 7 atoms of oxygen, right? But this is by simple unitary method, okay? What is the actual method of telling us? Okay, see this. If I have written 7H2, but you please understand this, okay? This is one entity, okay? This is the molecule. I will keep on changing the coefficient. I will keep on getting different number of molecules. I'll keep on changing the coefficient there. I'll keep on getting a different number of molecule, right? But still, whatever the number of molecule, what is still same? The constituting elements are still same. What is still same? The constituting elements are still same, right? And the atomicity for every element for this molecule, and the atomicity for every element for a particular for a particular molecule will be the same, right? Example, even if we have 10 H2O, we will still have 2 atoms of hydrogen in 1 molecule of water. That is what is atomicity here. Just try to relate that concept, right? Now see, how do we get to know the number of atoms present in a certain number of molecules? How do we get to know the number of atoms present in a certain number of molecules for a particular molecule? See, whatever number we have for the molecule, please try to focus with you. Whatever number we have for the molecule, here we have 7, right? That is for every element present inside it. So can I say that 7 is also for hydrogen and 7 is also for oxygen? Yes.
Yeah, ma'am.
Now the atomicity for a particular element, please mute yourself. All of you, please mute yourself for some time. Fine. This 2 is for a particular element, and that we see is the particular atomicity for hydrogen here, right? But the camera should be on. 2 is the atomicity here for the hydrogen element, right, in this molecule of water. So 2 is only for hydrogen. And if nothing is written here, I assume that is 1. I already told you if nothing is written here, that means it's 1. So now see, 7 and 2 are for hydrogen. I will just multiply the numbers whichever are there for a particular element. Here there are 2 elements, that hydrogen and oxygen. And for hydrogen, what are the 2 numbers involved here? 7 and 2, right? So I'll just multiply them. For oxygen, what are the 2 numbers involved here? 7 and 1. So I'll just multiply them. And therefore, I'll get the number of atoms of the respective elements in the respective molecule. Is that clear?
Yeah, ma'am.
Yes.
Last question here based on this. Last question. I need to know the number of molecules, elements, and atoms quickly calculated. I can ask any one of you. No one will answer from his side. Quickly, all of you, very quickly. Molecules, elements, and atoms, all of you mute. I'll mute all of you. Fine. Calculated, then we'll end the class.
I got it now.
Ma'am, God.
Yes.
20 and 40.
Yes, Faraz, are you saying the same?
Yes, ma'am. 20 for
Just
hydrogen.
a second. Just a second. I asked that. I said that I can ask any one of you. No one will answer from their side. Mute. Mute, all of you mute. Bethel, first tell me how many molecules are here?
10.
10 molecules. Bethel, tell me if I change this 10 to 8, okay, let's suppose to 8, will this change or will it remain the same? Because this is a particular molecule.
Then it will change to 8 molecules.
Will the configuration here change? Will the configuration composition change? No. What is changing? Just the number of molecules, yes? The number of repeating
ma'am.
units of this particle, right? Fine. So that is the point. I hope that is understood of all of you.